Okay, so for this interview, you're gonna have like at Facebook a pretty much similar interface to this. From the upper right corner, you can select the language you want. So now it says plain text there. Perfect. Okay, so pretty much you're gonna have the same interface. Main difference is that you're not gonna be able to run the code. So in this interview, we also don't want to run the code. Um, so I'm gonna paste the requirements of the first problem there and explain a bit what we want to do. For the purpose of this interview, we don't want the code to be perfect, so it's okay if it doesn't compile, but we want to be as close as possible to the actual APIs. Now, I'm gonna paste under here what we want to do. So we want to check if a matrix is a Toeplitz matrix. So you can imagine that we have like a given matrix, kind of like the one that I'm writing here now. So a Toeplitz matrix, a matrix is a Toeplitz matrix if every element on the diagonal is the same. So going from top left, bottom right, we have the same element. So in this case, you can see like there's a 1 here, there's 1, 1. So going from top left to bottom right, above it there are only 2's, and above there are only 3's. Finally, you have a 4 in this corner, and that doesn't matter because it's just like 1. And under the main diagonal, there are like 5's. And finally, under that, there's a 9, which again doesn't have a pair, so that's totally fine. Since it basically fulfills the condition that every element on each diagonal is the same, then we're just going to return true.
Okay. So first thing, let me take some notes. So basically, we have a matrix. I wanted to check that. So the first is the definition of all diagonals. And the second thing is like for each diagonal, I want all the items to be the same. Okay. So I think that the first thing that I'm going to clarify with myself here is how can I get with the diagonal? I mean, what is the pattern? It's very easy. The first one. So it looks like it's all in the direction from the top to the bottom right. That's correct?
Yep, top left to bottom right, exactly.
Okay. So if we start with the main diagonal here, is like okay. This is basically okay. What I'm doing right now is trying to get the pattern how to iterate for one of the diagonals. Initially, I can say okay, you can start starting from for instance, one of the diagonal could be 1, 2, 3, 4. Okay, so basically for each eye. So for example, the first diagonal will be 0, 0. The second one will be 1, 1, 1. Then 2, 2, 0, 1, 2, and 2. Okay. So the next diagonal is like 0, 1, and then 0, 1, and then okay, I just assigned to comment 1, so it's basically 1, 2, and then basically 2 and 3. Okay, so basically here we are incrementing by 1. Actually the same thing here, incrementing by 1 after you have the root, the source point where you are, yeah. But actually, yeah, that's correct. We're incrementing by 1, route and core, and the same thing here. So just to give you some visibility, because I'm brainstorming with myself, but basically you are not following me. I'm just brainstorming right now about the patterns to iterate the matrix with this to make these requirements. So the next one would be 0, 2, just to confirm my hypothesis. 0, 2, 0, 1, 0, 1, 2, correct? And the next one would be 2, 3. Yeah, because basically I'm moving 1. Yeah, basically I think that the summary, so this is basically the same. So basically I think, well, actually, hold on. This is one trick. Yeah.
Yeah.
So basically the pattern here is like, okay, after patterns observations, it's basically after you fix like pivot item, yeah, after you fix a pivot item, you need to go one right and one down, which basically means +1 for calls and rows. Okay, so that is the upper part of this. What about the 5 and 9? So for 5, in this case, we have for 5, for 5 it's exactly the same basically, because the only thing what is different is like for 5 like 0, 1, no 0, and then the next one would be, according with this pattern, would be 2.1, if that's correct, 0, 1, 2, 1, 1. Yeah, that's correct. Okay, so basically, okay, I think that I got the pattern about when I have a source, how to iterate to the rest. I think that the next logical question, the source. What is the source? What should be the source for this one that the other? It looks like the source, based on this example, and probably for the rest, for the definition of the source would be for basically all the items in the first column, all the that in the first row, and all the items in the first column. Yeah. Okay, so basically, if I have seeds, will be like items in first row, and I think for rows, item in first columns. In first column. Okay. Okay. Yeah. Basically, what I need to do in each one of these iterations is to check that everyone have the same item at the root of the source. If that not, I'm going to return false. Okay. I think, Ted, at this point, I feel. I'm not sure. I have been speaking out loud. Probably I'm going to reframe. But basically, what I'm thinking is like. Basically the algorithms or the process that I'm thinking is like, okay, first of all, I'm going to pick one of the seeds or the source or the root, depending on the diagonals. And after that, I'm going to iterate. And the pattern to iterate, the diagonal with this requirement will be basically incrementing one by the column and one by the row after you have your seed item. And basically, I'm going to check where these items are equal to the source or to the root value on that diagonal. If that's the case, I'm going to continue. Otherwise, I'm going to return false. If at the end of all this iteration I haven't found any discrepancies, I'm basically going to return true. So basically, that is a high-level review about the algorithm. Basically, the complexity solution of this will be linear. I know, yeah, will be linear. I know, basically, I'm not repeating any state of every items. In the worst case scenario, we have a square fit matrix. Yeah, it will be kind of linear. Yeah, yeah, it will be linear. So yeah, that's what I have in mind. What do you think?
Yep, that sounds good. Let's go to coding.
Okay. Okay, let's go coding. For coding, let me organize how to want to do this. First thing, the seeds, and the first thing. Okay. So we have something like role matrix. What is the a name for this? Like, I know, something like shape diagonal, something like that. So we have a bidimensional matrix here. Okay, the first thing is like we need to check, we need to see the roots. Basically, the root will be like first round and first column. Okay. So I think that one way to do this is iterate for the first round. So basically, what I'm thinking to do is like, okay, we can do this I'm going to tell for the first row, I'm going to say, hey, consider the matrix, let, one, a plus plus, so maximum I want to say is like, if valid diagonal, if simply if is by diagonal. Okay. Yeah, if it's solid diagonal, I'm going to pass the matrix, I'm going to pass the source. In this case would be 0.j. And I'm going to pass the value for I have to check, which is basically matrix in 0.j. Okay, if this is actually if not, simply I'm going to return false. I'm going to do the same thing for the first row. Simply the first row, just to avoid confusion with myself here, so basically would be the rows, C++, so basically it's not valid diagonal matrix in I dot 0 the columns equal to 0, it is not return false, otherwise we want to return true. So that's a template. Let's now implement quickly our it's valid diagonal method that basically would be is valid diagonal here it should be is uppercase. Okay. So let's continue. So we have basically our matrix here. We have the index, basically the seeds, and where we have the voltage pair. Okay. So at this point, let's check. Basically, we want to move one right on the left. So basically, what we're going to do is like while basically while I less than matrix dot length 0 j less than matrix dot length in 1. Okay, this happened. I just want to check. Okay, if basically matrix in I dot j is distinct to the current bar, I'm going to return the reference bar. I'm going to return false. Otherwise, we are going to do G++, J++. Basically here, we are going to return true. So this is basically a template solution. Let me review this. Okay, what I'm missing here. Okay, I just checking for rows. Is one of the rows, is one of the columns. Returning true. What about this? Let's do some unit tested. So if we have is valid diagonal, this is the reference, the poles, and then I'm moving one down and one to the right. What mean one down and one to the right? E++ is going down. E++, okay. Is this correct? Yeah, it is correct. That means I won't be okay. Okay, at this point it looks like a working template for me. I think that I would like to do right now text is like do some unit testing, manual testing and tracing about my code. You think that you are okay with that?
Yep.
Okay. Okay, what I'm going to use is like a small example. Tracing manually is time consuming, so I want to be sure that I have a good strategy and not spend too much time. Since I'm assuming that we have another question here, so obviously to use this example, we should return true here. Okay, let's start. The way that I'm going to do this is like going to test it like the unit test scenario. So the first thing that I want to do, I'm going to test this function first, and then assuming that the function is correct, I'm going to test this part.
Yep.
Okay, so for each valid diagonal, let's forget everything. What about if for this example, I've got the input like the matrix that we have above in the line 8A, and what about we have 0.0 like the source, and basically the value will be 1. So what I'm going to do here is I will say, okay, I initially 0 matrix get length in 0 will be equal to 3. So basically we are doing that is 0 less than 3. J will be equal to 0 as well is less than get length of 1 will be equal to 4. This is going to return definitely true. So we're again here, and we'll say, okay, is matrix in 0, distinct to val? And the answer is false. It's not distinct to val, it's equal to val. So we're not getting here, and we're going to say, okay, E plus plus, okay, E right now is 1, and J is 1. Okay, so again, now we have 1 less than 3, 1 less than 4, this will be equal to 2 again. So the position in 1 and 1 is 1 again. So basically, it's 1 distinct to 1, and that's going to return false. So we are moving here, we are 2 and 2. 2 and 2, what happened? In the next iteration, we have this 2 less than 3, 2 less than 4 is going to return true. This is going to say matrix in 2 and 2 is 1, this into this is false. Okay, we're moving here 3, so now we say is 3 less than 3 and 3. Okay, this is going to return false. Both conditions are not met because we reached the end of the row. And basically, this is going to return false. So we are moving out the y. I'm going to return true, which in this case is expected. Okay, what about specifically a case scenario here? What about we have, for example, 9. So for this example, how the code would react. Basically, we have 9. We're going to enter like 2 dot 0 1 2 dot 0. Okay, in this case, what happened with the code? The code will be say, okay, instead of I 2 less than 3, 0 less than 4, this is going to return true. So this is going to say 9, this into 9, this is going to return false. So we are moving E plus plus here, so E will equal to 3 and J will equal to 1. So then here 3 1, this is going to return false. To return false, matrix. Yeah, this is going to return false, so we are getting out the y, we are returning true, it's expected. Okay, what other specific case? Okay, what about the corner at the top right? I'm going to do that just by vision, just to save it some time. But basically, in that case, we have 0, 1, 3. Sorry, we have 0 and 3. We have 4, and we have in here, we have 0, it would be 3, will be false initially. So 4, this into 4 is false, we are good. So E plus plus will be equal to 1, J plus plus equal to 4. So in the next item, I have 1, I have 4 here. This is going to return false. Okay. Okay, I think I'm going to make a pause. I feel a bit more confident that this is kind of well tested. So I'm going to assume right now that that's okay. I'm going to test quickly the main function, assuming that this is okay. So for this example, for the basic example here, basically what we are going to do is basically iterating for the first, this is basically, let me put some comment here, but basically it's like first row, and this is first column. Okay, so j equal to 0 initially we have j equal to 0. So basically what we are entering here, I basically the only thing that we need to test. What we are entering here is like f in 0.0 initially with value 0.j, basically with value 1. Assuming that that's correct, this is not going to return true, so then I'm returning f in, I just moved j, so I'm going to return f in 0, 1, then returning f in 0.2, then I'm calling f. F would be the is valid diagonal. I just writing down f because it's simpler, it's faster. 0 is 3. Okay, and then 1, just the floor. And this would say for less than get length is 4. So this is going to return false. We are out the loop, and this is symmetric 1. Let me see, I didn't do any. Okay, this is 0 instead of 1 because the row is high, and this is inverted. So basically we are calling here now like 0, 0, and then we are calling 1, 0, and then we are calling 2, 0, which is expected. Okay, then at this point I would say that I feel confident with my test. Probably the next thing, so the last thing that I would like to think about is what about some kind of specific aware matrix. So what about, for example, for this case when we have matrix like only one column, something like this. So in this case, well, in this case, this is not gonna run because there is no. Well, it's gonna run for the first one, and then yeah, something that I noticed is like I'm repeating the first item. It's not something bad. I mean, but it's not necessary. That I'm repeating the same, the top left item I'm repeating when I move from this 4 to this 4. It's not causing any major issues, but it's definitely a point for optimization. Not sure if we want to fix that because it's not causing issues, just like it's not necessary to do it. But basically, one way to solve that is to start from is equal 1, for example. So we'll need to check the first item again. So what else? So in this case, this is gonna run one first, and then we're going the rest of the item here. 0, 0, 0. Okay. Yeah. What will happen here when we don't have any more items? Yeah. Okay. This is what it says. Okay. Okay, I feel confident with that. What about we have the scenario is only this? Okay, that's okay. What about we have only one item? The matrix, yeah, they will be running by here, by this. They won't be executed because we are starting in equal 1. Okay, what about NG matrix? We have an NG.
To be honest, I think this sounds good. I think we can also try like another problem. What do you think?
Oh, yeah, sure. Go ahead.
Okay, awesome. Okay, so under this, on line 80, I'm gonna paste the requirements of the second problem. So this time what we're gonna do is, this one is gonna be a bit harder. You're given a string containing only 3 types of characters, open parenthesis, close parenthesis, and star. We want to return true if the string is valid, and we define the validity of a string by the following. Any left parenthesis must have a corresponding right parenthesis. Any right parenthesis must have a corresponding left parenthesis. Left parenthesis must go before the right parenthesis. And up to here, it's pretty much like valid parentheses, like they just close out and everything's okay. The tricky part is the star. So star could be treated as a single left parenthesis, a single right parenthesis, or an empty string. Now some examples, if you have like open close, this is obviously true. You can also have something like, let's say this is also true. And of course you can also have like stars to close. Let's see something like this. This also returns true because you can consider one of the stars as empty string and the other as a closed parenthesis. But if you have something like this is gonna basically return false because there's no way of closing the parentheses in this case.
Okay. Okay, so let's do the same again. Okay, let me write a note. Okay, this is basically, okay, let's simplify the problem first, because what is probably tricky here, how to handle the star. Well, basically, without the star, it's just, a simple machine parentheses problem, which can be usually solved using kind of a stack or counter for balance approach. That kind of thing depend on the context. But let's say that that's the problem. Okay, I have a pretty good idea how can I solve it without a star. So the challenge for me now is the star. That is what is new. Okay, let me see. I think that what I need to do right now that is just to play a little bit with examples. So you say that this is true. I'm curious about this one. So this is true because basically a star we add like a closing parenthesis. We close this one. Hold on. Just double checking. Are we sure this is true?
Yeah.
Okay, I'm trying to understand why it's true. Yeah, could you? Oh, sorry, 1 second.
Yeah. So the reason why it's true. Yeah. So the reason why it's true is because basically you're missing one closing parenthesis, right? But you could basically consider this as a closing parenthesis, and basically this as an empty string. So in that case, it would return true. You can also do the reverse.
Okay. Just I missed it in the line 89. I missed the last part. Okay, I see. Okay, I understand now. Okay, so basically, star is like common. Okay. All right. So how can we handle this? This is a decision problem. We have to return true or false. So one thing. Okay, what about an optimistic kind of greedy approach? How that sound? Let me see. If I have that, I would say each time that I found a star will be whatever I need. Let me see. For example, in this place, I would say I have open. I have a star. Oh, you have a star and you have an open one. Okay, I'm going to assume the star is closing that open one, but I don't want to do that always because the problem is that in this case, for example, okay, let me not remove example, but for example, that greedy approach doesn't work because in this case, that should be true as well because this is matching this and this is matching this. Okay, but the problem is that you can be, in this case, this could be an empty string. So in this case, if I treat this star like an open or closed parenthesis, it's premature. Basically, they will be wrong because if I'm talking like closing, I will be closing these two. Basically will be invalid. So basically, the conclusion of this is that I can't take a decision on the closing one. What should be before knowing what is behind. Okay, so what about if I not close I know use it, I just keep it like something useful for when I need it. For example, right Right now, I don't have any good answer. I just playing with sample set just to
Yeah.
give you some visibility. If I have open, parentheses here. Um, okay, what I'm going to do, what I'm going to say is like, okay, forget about parentheses. Sorry, forget about the star, and let's have a separate queue, then a star, just to say, okay, you have something there. What you are going to say is like, I can visualize this like something that I needed at some point. Okay, then I have a closest parenthesis. So I have a closest parenthesis. That closer will be matching this, which is fine. So basically, if we have a star, but what is around the star is matching, I can treat all the stars like empty strings. So okay.
Mhm.
So in this case, I'm going to close that, and when my algorithm finish, this queue will be empty, which is fine. The star queue won't be empty, but that's not a problem because I can treat it when I don't care about where it is, what is the position where it is, I can treat it like empty strings. Okay, I think that I'm making some progress here. Let me validate 1 second. Let me do with this example, for example. In this example, I would say open, okay, open. Okay, you have a star. Let's do it separate. Now you have closing parentheses. Okay, I don't want to close the parentheses with this one, and then you have another star. I'm going to put it there. Okay, and you finish your algorithm. So what happened? You happen that you have, okay, but I can use the star to match in that, and the answer is probably, but not always, because what the star is at the beginning. Okay, yeah, because I can have this situation, and in this situation, there is no way that this is true. This is going to return false.
Mhm.
Okay. Mm, okay. Let me try with more complicated example. If I have
Is there any way to actually? So I think you present like yeah, you have like the situation. Is there any way like with the current solution that you mentioned, so you end up with this, to know if you can use or not use basically the star?
yeah, basically I can put it a position, right?
Mm-hmm.
I can store in the queue the star with the position of that star. So in that way I know if I can match these two or not.
Yep, that's perfect.
Yeah. The only thing that I'm not convinced about that. So it's like I still my brain is still a bit confusing. I think that I need a more complicated sample to get me out the doubt. Uh, so for example, in this case, we should return. So this could be okay. This could be open, whatever, close, mm, close. Okay, so this is valid. Everything can be empty here. Yeah, the problem is, what about with this one? They will be closing what? They will be closing what? Maybe, yeah. They will be closing what? Yeah, I think, okay, one way to visualize this, for it, I think this should be false, right?
Sorry.
Do you think that this example on line 125 should be false or true?
On this one, just a sec. So this should be true.
It should be true?
Yeah.
How you made that true?
So basically you can turn this into close parentheses and this to into open.
Yeah, correct. And the last one would be empty string.
Yeah.
Okay. I think, okay. In this example, using the strategy, where we say we have open, open. We have a closed one, basically 0, 1, 2, position 2. So then we have closed one. Basically, this example, I think that what I'm missing in my idea is when should I use the close parenthesis or when should I use any commodity that I have here. So if basically okay, let me reset. So for the closed one, I'm closing this. The balance I use the grid, I'm not sure even if I could close, but let's say that it would be a wrong move because the only way that this could be true is that I need this taking the lead here. So probably why we do the same. So okay, you have a close parenthesis, but if you have something here, you should use it first. Okay, if I use this, I'm going to remove this. And then what about next? So I'm going to move here, I'm going to move here. And then we are moving this, so we have the same scenario. We have the 0, 1, 2, 3, 4. Then we have another one will be equal to actually with 5. Then we have a closet, but there is nothing here. There is nothing here that is open. Okay, in that case we have the common. You have the common in. Oh yeah, you have something in the previous position. I'm going to match it with this one. That's good. Then we are in the curves and we have the same scenario. Okay, we are good. Then we have another asterisk. So a star that will be 0, 1, 2, 3, 4, 5, 6, 7, 8. We finish. The only thing that we have is a star, so we are good based on the definition. Okay. Okay. I think I have a good idea how to do it. I think that I need to write down the rules in order to avoid confusion. But basically, the rules would be there's different scenarios. So we are going to save. So basically, brush. Basically, we are going to save open and close it. Sorry. Save open parenthesis stack of Q stack is fine. Open parenthesis stack. So now I'm save stars position. Actually, I can have a separate stack for this, so I don't need to save the position. So basically, save stars positions in a separate stack. And now it's coming the scenarios or rules. When okay, one thing is like basically one thing is like if one case is like case when I have a closed parenthesis. If you have a closed parenthesis, we need to check basically if exists a star, we should prioritize to closing the parentheses. Hold on, as in a rule case that I have a closed parenthesis. If I have a star, if I have a star, I probably, well, I'm not sure about it. To be honest, I think that I close it, but I need to be complete. I'm going to be honest. I think that I can tell you right now an approach But to be honest, I feel that I will take the risk because, to be honest, to be completely sure about this, I feel that I need more time to test with more example. So the only option I have right now is to take the risk and say, okay, I think that this is a workable approach, but to be honest, I'm not completely sure. So it could be mistakes there. So what do you think, or how do you want me to proceed?
Let's go forward with like the thing that you had in mind. So basically the solution.
Okay. So here, basically the intuition I have right now, should the closed parenthesis always close a star? Or depend if I don't have an open one? Because in this case, I close, yeah, okay, this is a star, open, this is closing, this one, oh, this one is closing this one. Okay, you have a close parenthesis, you just have the doubt right now if I should close, I should match it with the star always, or I should match it. Okay, I'm gonna take a range, but basically if I see a star, match, closed parentheses with stars available. If no, if there is no stars, yeah, I just have to match it with matching with open parentheses. So what about if we have a case where it's like the case for stars? Is when I'm getting the character is in a star. I don't know anything, I can do anything at that point. So basically the only thing I'm going to do is like just save or store the stack. At that point, well, actually in this example, I match it with the left, but I'm not sure always. Okay, I think that I'm missing something here. It's like, what is the most simple way to solve this without any doubt that that will work, right? And the most simple, I'm trying to find an optimal approach. And probably forget that the most simple way to solve this is probably do a combination of stuff that would be super super inefficient. But I'm pretty sure that if I get a star and I get the different interpretation that star could have, I will be able to solve the problem easy. The only problem is that that is very inefficiently. So what we are doing now is basically trying to find a better algorithm for that. But I never mentioned that there is a straightforward approach with combinations. So for stars, intuition is to store the stars in a stack. But the issue is like in this example, the only way this can be true, we need to close. We need to add the star like the closing parentheses. But in this case, it doesn't matter. We are closing here. We're going here, and then we're closing this one. Then what about this? What about? Okay, we're closing these two here with the closing one, and then we have this. Okay, we need to match this with anyone from here, so we match it here. Okay, that's fine. Okay, so yeah, I think that will work. We can do at the end. So case start the starting in a stack. It's open parentheses would be la store. Yeah, basically a store open parentheses as usual. And what is tricky here was at the end we have similar scenario. After iterating, we can have a stack one, the parenthesis one, empty. If this happens, we can return true. We don't matter about what is in the stack. If not, we need to start to process basically. If no, we basically need to say, okay, for every open parenthesis, check if there is an star with a position less than the parenthesis that you can match. Okay, that is basically approach what I'm missing here. Yeah, the only thing that I still not sure is where we want to, for the closest parenthesis, if we want to match it or we don't want to match it. But basically, if I have, this is a good example. I don't want to match it because if I have this, I have this, basically I don't want to match it. I don't want to match it first. Not try to match it. Well, if it's this star, so this is wrong. This is the only thing that I think is wrong in my approach. Basically, the behavior that it's a C star match the closest parenthesis with the star available, that's not true. Because if I match this with this, well, actually that could be true. If I match this with this, I could treat this like a closed parenthesis. Yeah. Okay. Yeah. Okay. Yeah. Basically, this would be interpretation, which is not bad. Okay.
What would happen in the case of basically this?
Yeah. In that case, in that case, the algorithm will say open. Yeah, there will be. I'm going to store this star, but then here, yeah, this is going to match this, so this is not good. That's why I say that this part is wrong. Yeah, basically that's the only part that I see is wrong. So how can we solve this? Is basically everything I can. The idea here no doesn't work. I think that we probably need to make this decision at the end and not ongoing.
So if you have something like this, is there in this case like when do you know that this is or actually like we can also have this, let's say, when do you know like the value of the star? So what does the star have to be? When do you know what the star has to be in order for this to be valid?
Yeah, in that case, nothing will happen. We're going just to save the stars in the stack, in its own stack, and we're doing nothing at that point. Then with the closing parenthesis, there is one thing. When we have the closing parenthesis, we need to be sure, we don't need to iterate the whole stuff. We need to be sure that there is a same amount of available item to close that parenthesis, otherwise an imbalance. Otherwise an imbalance a chain. Basically, we need to be sure that we have the amount of open parenthesis or star is greater than or equal than that open parenthesis. So basically, we need to have one star or one open parenthesis, right? In this case, we won't have any open, but we have a star. So we can say, okay, we can close it. The problem is like, what I'm not sure is like, so basically in other words, initially we're going to store that star, and then in the closing one, when we say that we have empty parentheses, basically we don't have a star, we are ready to return false. That is not possible, there is no chance there. But since we have an open star, there is no option that to take that one, the last one, to take that one to match in the closing parenthesis. So in that case, I think that it's a single star match the closing. I think that the order of this is what is probably not correct.
Yep.
Probably I need to check first. Probably if there is open available. Otherwise, check for stars.
Yep.
Otherwise, we're ready to return false because there is no way to match a closing parenthesis. Yeah.
Okay, so to be honest, this sounds really good. We have about 8 minutes or so left, but we can go a bit over time, so it's totally fine. But I would rather spend the remaining time to give you feedback.
Yeah, that makes sense. No, yeah, that
Uh,
makes sense. I will appreciate that. Yeah.
So before I move to the actual feedback, I would like to explain a bit how you're going to be graded at the interviews in general. So you're going to have like three types of interviews. So it's going to be coding, architecture, and behavioral. Most loops are going to have two coding, one architecture, one behavioral. You might have more or less depending on that if on the level you're interviewing for, or basically if Facebook wants to have like we also have like basically training sometimes. Uh, Also, so you're gonna have like might have like one interview or so. Um, and basically the way we grade these interviews is that for the coding, you pretty much have a decision, obviously like higher or no higher, and levels of confidence. So low confidence, average confidence, high confidence, absolute confidence. And now this is like for coding. For behavioral and architectural, you also have the level for that you consider that. So basically, you might say at the end decision something like this person is a higher at E5 with average confidence, uh, and this level of confidence is really important because there are like basically two interviews which check for coding abilities, the coding interviews, and two interviews at least which check for your kind of like your level inside the company. So basically, if one of them says something like uh, low confidence, no higher, but another one says average confidence higher, it's very likely that they're still going to be hired or at least have a follow-up interview. So even if you don't do that great at one of the interviews, you can still pretty much get hired or have like a follow-up interview.
Okay, good
Now,
to know.
each of the interviews, yeah, let me know if you have like any more questions on this or if you're curious about anything.
No. Please continue. I'm listening. I'm paying a lot of attention to what you said. Yeah.
Okay, perfect. So each of these interviews has some axes that interviewers are looking for. This one has just four axes. So it's basically communication, problem solving, testing, and coding. So I'm gonna start going through each of them. So for communication, I think you pretty much did well. You expressed very well what you think of doing, what your plans are, and you explained the problem. The main thing here with communication is to be able to explain the solution that you plan to have to the interviewer so that they can help you if you're stuck, need tips, and for the interviewer to just understand that you're on the right path. So on this one, I think you did really well. Don't have huge concerns. So you explained really well how things are going to happen. Sometimes you can even have like you have a tendency of like writing a lot, which I think is totally fine if it helps you. But you can also just like if you feel the solution is like simpler, you can also try to explain it like just with words or like just sketch something really simple. This is kind of like totally up to you. The only thing to be careful of is kind of like time, because it's basically the general expectation is to have either two medium problems in 40 minutes or one hard problem. And most of the people are actually going to have two medium problems. Since I brought up like number of problems, and so I also want to mention that Facebook will not have dynamic programming problems or problems that have dynamic programming solutions only. So yeah, that's not something that we encourage to do, and interviewers won't give those type of problems. Uh, the for this here for communication, I think you did really well, so don't have huge concerns. Next one is problem solving. So I have some feedback here. The thing which I noticed is the first problem. I mean, it's I think you got to the first problem solution really fast, and that's pretty much great. The thing is that I think you spent quite a lot of time trying to like validate the solution, which is again it's totally fine if you're like not unsure or uncertain of the solution. Can you hear me? I think I
Yeah, I can hear you.
Okay, awesome. So I think it's totally fine if you're not unsure of the solution. But if you are pretty confident, you can like move faster to coding. My general feeling is that we spend quite a lot of time like trying to go through the like trying to extend the solution and so on, and then spend quite a bit of time on testing, for example. That's totally fine, but like on the first problem, kind of, it's more about like trying to figure out like if you can code and test, kind of, which you pretty much did. Um, so that's kind of like the only feedback I have. If you can come up with like faster with the problem solution. On the second one, I think you did like pretty good because this is like a tricky problem and it's way harder. So I'm totally happy with that. But on the first one, I think it could have like went a bit faster. The and I also like let you to just because like you're explaining pretty well. I felt like you have like this process where you can like come up with like a good solution and so on. So I didn't want to rush things. Um, the next thing is basically testing. With testing, yeah, I think you did really well with testing. Some feedback I have, like I'm not sure if it's possible to have like things like nulls, for example, for the matrix there. But yeah, I think you brought up some edge cases, which is awesome. So yeah, like try to do that usually at the end when you start testing or in the beginning when you're thinking like of how to solve this solution and so on. Totally up to you, but try to always mention edge cases. Something else which I forgot to mention is like also good job on mentioning time complexity. You can also consider like sometimes advantages of like sacrificing some time complexity to save space complexity, sacrificing space complexity to save time complexity, etc. But in general, we want the solution which is like most optimal from a time complexity point of view. And in general, we're not going to care about anything else besides big O complexity. So even if you, for example, I don't know, if you reduce it uh, from you just improve like some little performance, it's not going to matter as much as you coming up with like the best big O complexity that you can. Uh, yeah. So always run tests. That was also really good. Um, you also came up with examples that cover all of your code branches, so like returning false, returning true, and so on. If you want, like on the first problem, for example, you could have also came with like a more simple example. So you could, for example, I don't know, run on a really small matrix, which is like 2 by 2 or something like that, 2 by 2 or 3 by 3, and just go really fast through testing. Because yeah, I think that one is not. I mean, it's also up to you. That one wasn't like the hardest. And I think like you pretty much had a good idea of what to do. Your code was really nice and clean, so that's really good. Um, that's kind of like the main feedback here on the first problem is basically if you can to move things a bit faster, it would be great because like you don't have a lot of time. If you're not sure, basically if you should think of more of things, you can also say like, yeah, so I think this is pretty much for the solution is or something like that. So you can also like ask the interviewer saying like, okay, this is pretty much for the solution. Is there anything else I should like look for? So if you feel confident that everything's done and there are no bugs, basically. Uh, yeah, so that's kind of like the main feedback for these problems. Be careful with time. And the last thing is basically coding. On this one, I think it did really well. I don't have huge concerns. Something else to mention. Some people are not paying attention to that, but basically this API, the language APIs, also have their own time and space complexity. So in general, be careful of those and try to also include them when you mention time and space complexity. For
Okay.
and in the end, I guess like as a decision for this interview, you kind of managed to solve both of the problems. Only thing is that we went a bit over time. So a normal interview is going to be like you spend like a minute or so introducing yourself, and then you have about like 40 minutes for coding. We spend like 5 minutes extra, which isn't that much, but you're pretty much able to come up with a decent solution with like not a lot of fans. So if I would be not to take into consideration the 5 minutes extra, I think I would go like with a low confidence higher basically. So you pretty much are there. My expectation is like the first problem is more about coding and testing. So are you able to like fit those two? and the second one is more about problem solving. And I kind of got like signal on all of these axes, and of course communication is like on both of them. So in general, this is what like interviewers are looking for. Do you have any questions or anything at all about this?
Not really. I think that your explanation and your insights and your details about the process and the thought process in order to give feedback is awesome and really very helpful for me. Thank you so much for sharing all that knowledge with me. Will definitely help me in my preparation. Yeah.
Awesome, that sounds great. So a suggestion I have is if you're doing problems off LeetCode or something, try to time yourself. And like in general, Facebook is going to give you like medium problems, so try to do some of those medium problems. And what you can also do is like try to time yourself, so try to solve them in like 20 minutes or so, and try to solve them without actually submitting the problem multiple times. Basically, try to also test and do everything, and try to take about 20 minutes or so. And when you press the submit button, you should pretty much pass like on the first try. In general, the idea is to like make sure your test isn't broken and just come up with a good solution and in good time, kind of. So I think this would be like a good exercise for you to try out.
Makes sense. Yeah, definitely.
Okay, sounds great. Let me know if there's anything else.
I don't think so, Ted. I think that I really appreciate your time for interviewing me and all the super insightful feedback that you have provided to me. It's very helpful.
Sounds perfect. Have a good day. Goodbye.
You too, Ted. Have a good day. Bye-bye.
Bye.